Let's consider the equation x prime equals x plus t. It might be tempting to attempt to integrate this function as follows. Integrating x prime, of course, we just get x being an antiderivative of its derivative. And on the right-hand side, we can write the integral of the quantity x plus t. And of course, that's equal to the integral of x plus the integral of t. And then we can say, well, the integral of x is x squared over 2. The integral of t is t squared over 2. Now, I've got big question marks around this because it's not so. Do you see the error in this assumption? Well, in case you don't, let's write this out really carefully. We would want to write the the integral of x prime with respect to t equals the integral of x with respect to t plus the integral of t with respect to t. That would be valid. The integral of x prime with respect to t is just x. We can have an integration constant which we can put on either side of the equation. Now the integral of t with respect to t is t squared over 2, and we might as well go ahead and put the integration constant here. The problem is that the integral of x with respect to t is not x squared over 2. The integral of x with respect to x is x squared over 2, but the integral of x with respect to t depends a whole lot on what the function x is, so that we have no idea what this integral would be. So we can't simply write the solution to this equation by integrating each term. We don't know how to integrate x with respect to t because we don't know what the function x is. I'll say that similarly down here, and I think we're just repeating this, but I've got a couple of side notes here, one indicating that we can integrate x prime of t dt by the fundamental theorem. We get just x of t if you prefer. But we can't integrate x of t with respect to t without more information, which we don't have. We can integrate the t dt. So we have to be careful that any integration that we indicate is with respect to the appropriate variable.